We have achieved great things. We have made giant leaps. We've gone far beyond what we thought was possible. But we have only just begun. Our future in space is unlimited, and it will benefit all humanity. But it will take hard work, new technologies, advanced financing models, and enabling public policy. The Beyond Earth Institute is creating a policy and legal framework to enable the creation of economically vibrant communities beyond Earth. We will engage all stakeholders on critical policy issues: property rights in space, norms of behavior, conflict resolution protocols, filling the technology gaps, exploring new financing mechanisms, and making space settlement an agreed goal of the U.S. and its allies. Beyond Earth is committed to the true purpose of why we go to space. Join us on this journey.
Well, good afternoon, everyone, and welcome to another webinar of the Beyond Earth Institute. I'm really excited about today's program. My name again is Steve Wolf. I'm the co-founder and president of the Beyond Earth Institute. Today's program on stimulating the expansion of human civilization via large-scale space migration is a little bit different from some of the policy discussions that we've had in the past. But I am really excited that it gets me to have on this program Frank White, who is an old friend of mine and is one of the leading space philosophers, if you will, the author of the Overview Effect. And as much as I would like to have a philosophical discussion with Frank, which we've had one-to-one many times in the past. Today, we're going to be delving into an interesting project that he and his colleagues have been working on to build a model for us to understand the potential of human space migration into the future. So I couldn't be more excited. You know, it also is very interesting times right now in the space sector. We're all aware of most of us are aware of the bombshell news that Jared Isaacman's name has been withdrawn as a candidate for the NASA administrator. And we don't know who his replacement is going to be. A lot of folks are disappointed, including myself. We have gotten more details on the so-called NASA skinny budget, which will reduce the overall spending by about a third, and projects a reduction in force of some 5,000 employees in the agency. So this is going to have a dramatic impact, particularly on the space science side. I know that we here are on this call, most of us are excited about the potential for the human space program, and there does seem to be a solid basis that those programs will move forward. The Artemis program, mission to the moon and onto Mars, the announcement by the president that we are going to go on to do a manned Mars mission in the future. So these are exciting bits, but overall, I think we have to be disappointed that the budget is being reduced in this way. So but we'll get through this and look forward to continuing to interact with you folks and looking forward to a great program today. I'm going to now turn over this discussion to Steve Hazer, who is our senior technical advisor. Just to give Steve a shout out, he has been a technologist in the space domain for over four decades, has worked with many of the legacy space companies, and he has really done a tremendous job for Beyond Earth over the last couple of years that he's been involved, particularly in overseeing the production of our technical research papers. And he is the director of the Leadership Council of the Beyond Earth. So with that, Steve, thank you for jumping in and being the moderator for this panel. Steve particularly has excellent. I think that the kind of technical chops that is needed to have this kind of discussion. So with that, Steve, thank you, and I'll turn the program over to you.
Yeah, well, thank you very much, Steve. I appreciate very much, and I want to welcome everybody to. I wanted to welcome everybody to our Beyond Earth webinar today. We're really honored today to have members of the Human Space Program team as our guests today. Their mission is to develop a blueprint for sustainable human expansion into the solar ecosystem. This group builds on the Club of Rome's Limits to Growth model and a collaboration with Ventana Systems Incorporated, which is using the VenSim systems dynamic modeling software to enhance understanding of this highly involved and complex problem. To give you some background on this modeling approach, systems dynamic modeling was developed in the late 1950s by Dr. J.W. Forrester. It provides a means to predict the impact of decisions to complex problems that has and successfully been applied to many multifaceted systems problems. It is being used increasingly to enhance the decision-making and for analyzing policies and strategies in a variety of industries, policy areas, and geopolitical regimes. Because it provides a means to document and deal with behavior of complex systems, it facilitates interdisciplinary discussions of real-world problems in a way that isn't possible in other discussion forums. Grounded in the theory of nonlinear dynamics and feedback control, it takes users and participants beyond the conventional simple linear thinking. Those things where, if then, it's more if, well, what about all of these conditions which feed into it? And shows the often counterintuitive long-term delay consequences of potential decisions. So for purposes of our discussion today, we'll be using the term off-Earth community instead of just space colonization or colonies. And this is to be more inclusive of future human space expansion and migration. And as we discuss this fascinating investigative approach by our panel. And with that, I'd like to introduce our panel. First of all, we have, as you may, if you haven't read our announcement, we have Frank White, who is the co-executive editor of Sentient Media, LLC, and president and board chair for the Human Space Program, as well as professor at Kepler Space University. We're also fortunate to have David Peterson as chairman of Ventana Systems Incorporated, and he's an expert and original developer of the systems dynamic modeling VenSim software. And finally, from across the Great Pond over in Great Britain, we have Anahita Nazami, research fellow at Birkbeck University of London and a chartered psychologist. She's also the co-founder of Earthscape VR, which is creating immersive virtual and extended reality experience inspired by the overview effect that Frank has put into play, as was indicated by Steve in his book, Frank's book, The Overview Effect. And she uses that to explore the potential of psychological benefits for both terrestrial and extraterrestrial settings. So, Frank, let's start with you. Can you tell us a little bit more about yourself and the human space program?
Sure, Steve. And first, I want to say I'm delighted to be here and to have our team here. I've always felt that Beyond Earth and Human Space Program have a lot in common. I think that we're all pursuing the same goals with slightly different approaches to those goals. So, yes, most people, I suppose, know me as the author of the Overview Effect, Space Exploration and Human Evolution. And in addition to that, I have also been teaching at Kepler Space University, as you mentioned. And certainly, I'm co-teaching quite a few classes with Anahita, and also am a co-executive editor of Sentient Media, which is a new publishing company that's going to focus on space exploration and other technologies. And it's interesting to think about the human space program and the overview effect. They really are connected because when I was coming to the end of writing the book in the first edition long, long ago, I realized from what the astronauts had told me about what they had seen and learned that exploring the universe was too big a job for one space program, one company. It should be a worldwide endeavor. And so I proposed that there should be a human space program. It would be global in nature, and it would include the efforts of other space programs that represented nations, but also scientists, space advocates, and anyone really interested in humanity's future, off-world, as you put it. Uh, and I think that uh, we've been very fortunate because we have been able to establish the Human Space Program as a 501c3 nonprofit. And this blueprint that you mentioned, we have three components to realizing the blueprint. One is we plan to have a series of task forces who will consider all the big issues as we leave planet Earth, or some of us do. And these task forces are going to tackle the big issues like environment, governance, etc. We're going to create a repository of knowledge for the use of the task forces, but it'll be open source for anyone. And then finally, we always thought we wanted to simulate and test our blueprint with a computer simulation model. And we'll talk more about how we came to know Ventana systems and how that collaboration began, because it's a great story how it happened. But the point of it is that having a model like this allows us in our effort to look at different alternative scenarios as we move beyond Earth. And we're again going to make that available. And people will be able to learn about system dynamics, which is a different way of thinking. And they'll be able to look at the questions of policy and practice through a different lens. It's almost like an overview effect conceptually of the roadmap that we're creating. I'm going to leave it there. There's a lot more to say, but that's why we have a panel. I think
Thanks very much, Frank. And that's quite insightful. And looking forward to getting some more better understanding of what this is all about, especially the model and its usage. And towards that effect, David, you have in fact put together a rather remarkable working and dynamic simulation already from what I have seen. Could you tell us a little more about yourself and give our viewers and members an overview of your simulation and modeling efforts associated with the human space program?
Sure, Steve. My name's David Peterson. I'm chairman of Ventana. Steve mentioned Jay Forrester. He was one of my mentors when I was in school. In fact, I was working for him already when I was an undergraduate, so I know a lot about the background of where computers came from and computer simulation. And one of Forrester's fantastic insights was if to understand what an important system is going to do in the future, you better understand the human aspects as well. It can't be just technology driven. And that leads to how on earth do you model human beings, because people are obviously extremely complex. And Forrester's key insight was that a really good model of a person sometimes is a feedback control system, sometimes called a servo. And so in corporate strategic governance, for example, a good model of management is sometimes what an engineer would call an ill-tuned servo mechanism, something that often reacts too late or overreacts, but you can characterize people in terms of how they react to various things in their environment, and then of course take into account that you can't possibly understand everything about them or predict what they're going to do, so there's a probabilistic aspect to it as well. But the idea is to model things in a way that everything that's important, including the human factor, is taken into account, so you can get a reliable anticipation of what will be the consequences of some investment or some policy. So it's easy to imagine if you're talking about people migrating off of Earth into off-Earth space communities, it's easy to imagine that that could help or hurt Earth and humanity in general. So it could hurt, for example, if the cost is extremely high and that money should be better spent taking care of the home planet, or it could help a lot if it actually improves the ability of humanity to control the environment, both in the off-Earth communities and the home planet. And it also depends on all kinds of trade-offs of technology and costs and human attitudes and all kinds of things. So the Human Space Program, under the guidance of Frank and his colleagues, is developing a comprehensive simulation model to show under what conditions, what would you have to assume or achieve in the way of technology or laws or anything else in order for off-Earth human communities to not only benefit Earth, but also humanity in general, and under what conditions is it vulnerable, under what conditions does it succeed. And the inspiration for that is a model that Frank noticed that was published a long time ago. I had a little bit to do with it, called the limits to growth model. And that was a model originally assembled by Jay Forrester and later worked on by a whole bunch of people to look at the future of the planet. At the time, there was no thought of off-Earth communities, but the question is, what is the likely fate of the Earth from the standpoint of 1970, where you have a finite planet, but you have exponentially growing human activity, populations, and industrial activity. And so the model for that is very simple, but it's also very comprehensive. So it deals with population levels, economic growth, natural resources, pollution, agriculture, food, that kind of thing. And Frank's idea was to add to that the possibility of off-Earth humanity and how the different locations of human activity might interact with each other in the same broad context as the limits to growth model. So we already have crude first steps in that direction going, in which at the same level of detail as limits to growth, we're looking at the opportunity for growth off Earth and how off Earth humanity might interact with on Earth humanity and under what conditions that kind of thing would survive. So a key thing we're adding to the perspective is the concept of attractiveness. Is it attractive for people to want to migrate off Earth? Is it possible? How many people would want to go? What is the attractiveness of living in one place versus another? How easy is it to visit either electronically or physically from one to the other? So that's what we're up to now, and if appropriate, we could even show a glimpse of what that looks like right now. So that's my job, is to help out on the modeling side of the human space program.
Wow, that sounds absolutely exciting. It seems to indicate that there's tremendous potential here, especially if it's an extension of the limits to growth activity, because that model, as you indicated, did not indicate or consider the potential for human expansion beyond, having an outlet valve, as it were. So it could provide some very exciting and informative kinds of indicators. So, Anahita, over to you. I'd like to ask if you could tell us about your background a little bit more and the role that you play in this human space program team.
Well, thank you for inviting me, both to Steve Wolf and yourself, to be part of this panel. It's exciting to be here. This is a topic that's close to my heart. The experts in this area are definitely David and Frank. However, I'm on board really as a psychologist and a researcher, and perhaps as an innovative thinker who likes to look at societal systems, including things to do with identity, culture, norms, as well as economic systems, to think about their impact on modern society, but also in terms of historically how they've impacted us, how these factors have impacted us. But also I've got a keen interest in space exploration and the expansion of humanity off-world, and really exploring, as David and Frank highlighted, whether this can be a beneficial venture for us that not only benefits the people and the communities that live off-world, but also benefits Earthlings and Earth itself. The model hopefully is paving the way for such things. I'm a researcher, as I mentioned. I'm also got a keen interest in performance, behavioral sort of science, and team dynamics, and all of those things that are common to psychologists and our work. And as part of Earthscape VR, as you rightly mentioned, we're creating digital therapeutics and programs that tap into salutogenic experiences like the overview effect, and they're informed by psychology and psychological theories and principles to try to improve mental health and well-being here on Earth, and perhaps one day off-world in some way as well. I must say also a special thank you, which I should have done at the beginning, to obviously the human space program and Frank and Stan Rosen and the whole team there, and of course David and Laura Peterson, for inviting me onto this project. It's a fascinating project. And as I said, I'm keen to think about these different systems that we can simulate through these models, and try to really look at these different scenarios that we can explore, that perhaps can pave the way for establishing what system could be effective for large-scale future expansion off-world. And I think it's fundamentally important. We have many projects underway with NASA, SpaceX, and Blue Origin, and many others, who are actively looking at whether it's space tourism or orbital systems and vessels, and moon orbiting vessels to try to bring these innovations together. And I think a model like this could really contribute to that.
Well, that sounds very interesting. One of the things that we kind of like to, this seems to lead to, and this goes to the entire panel here, the old limits to growth model. As I recall, it was a fairly limited model at the time it was put together. I mean, because it was a first cut, and some of the results did not seem to give an indication. And one of the things that that I think everybody really needs to understand is the job and purpose of system dynamic modeling, and I've used it in the past as well, is not necessarily to get a right answer, right or wrong answer, because in fact the results of a model, have a number of factors when I've used them and been involved in them, as to their accuracy. And the fact of the matter is, they're not necessarily there to tell you this is what's going to happen. It's a question of what could happen, and and David, maybe you can shed some light on this as to the basis that the results are very much and dependent on what the model has, how complex it is, and more importantly, what are the inputs you have? David, can you comment on that?
Yeah, the purpose of these models is not to make a prediction in the sense of an astrology prediction, where the model says this is going to happen, and will it or won't it? The issue is, what are all the modes of behavior of the system? What might happen? There was a big misunderstanding around the Club of Rome model that it had made predictions. And the only thing that's accurate about that is the plural of predictions. It looked at all kinds of things that could happen depending on various assumptions and things. So I noticed in the chat to this meeting that someone mentioned Julian Simon. So around the time of limits to growth, Julian Simon, who is a distinguished economist, placed a bet with one of the people who are alarmed about the future of Earth, Paul Ehrlich, I believe. And so to make it concrete as to whether Ehrlich's doomsaying was correct or not, they bet on whether various basic commodities would increase or decrease in price. And Julian Simon won the wager. The expected increases in prices didn't happen. Those expected increases in prices didn't come from the limits to growth model. They came from Paul Ehrlich. The limits to growth model said that if the Earth is in a mode in which the limit to growth that's most active is running out of resources, then it showed sort of a slow motion grinding to a halt of economic growth. It didn't say anything explicitly at all about prices, but it wouldn't be hard to imagine that in that case, various things might cost more. But the book didn't say that that's going to happen. It said that might happen. And it said, you might say, well, we don't want that to happen, so let's imagine a set of initial conditions in which resources aren't a problem. And you don't run out of resources so quickly. It said, oops, there's another problem there, which is called a pollution collapse, where the buoyed by unlimited resources, industrial activity on the planet grows to outscale the capacity of the environment. And then you get some sort of pollution collapse. And pollution wasn't even named, it was just called pollution. The most obvious candidate for that these days would, of course, be greenhouse gases. But even if that problem is solved, there might be some other thing of microplastics or whatever it is that's causing Parkinson's disease to rise. So the idea that somebody made a prediction in 1970 based on the Club of Rome is false. Other people were making predictions, including Paul Ehrlich. So the Club of Rome has been completely invalidated in the minds of some people who didn't read it carefully, or we could get into details of all of that. But there have also been books recently saying, oh my gosh, the Club of Rome nailed it. We're in deep trouble just like it predicted. So I think both of those attitudes are naive. The objective, certainly of human space program model, is to look at dispassionately at what would it take for humanity to benefit from space migration. And that we already know is a stiff order of a lot of things have to happen. And the question is not to get all excited about we're in favor of this or we're in favor of that. The question is what is a good design, so to speak, that would merit such a thing, or would even enable it, because it's not just a question of it being feasible, it's a question of would humanity tend to want to do that, the attractiveness issue. So that's, we're trying to stay outside of the Julian Simon Paul Ehrlich dispute.
That's a real good insight. You know, this kind of raises a question to probably a lot of viewers, and Anahita, you piqued my interest when you talked about some of the folks that you've been talking to. So that kind of raises the question, is the model and the activities of the human space program at this point, or is it at a point where it might be able to be used, or possibly through interaction with some of these other folks, extended as far as the model is concerned, to better understand the impacts of their proposed activities? Or maybe, I guess from what Steve said, is the model at a point where we might be able to use it to better understand the possible impacts of the proposed NASA budget reductions? Did I hit you hard there?
Well, I think this question is probably better placed with David or Frank, but I'll make a sort of start and then hand over. Again, from my perspective as a psychologist, I certainly think that once the model has been fully formed and the product is fully developed, then certainly it can, and again, David can confirm or dispute this, it can be used to inform policies, and it can be used to inform government. It can be used to inform societies in different ways. Of course, I think there may have to be tweaks done in terms of the output and input, in terms of the stocks and flows. And again, David, I think will be better placed to answer that. But from my perspective, why this model is the systems dynamic model is so interesting. It can develop these different scenarios, and as David says, try to elude the attractiveness of these different scenarios in relation to human space expansion. But also it can look at population growth in these communities as they expand. So looking at that is of interest. Looking at the expansion of communities is of interest, not just to space organizations and institutions and corporations, but also to governments here on Earth, because it really can serve these types of model as a bit of a test bed for what could happen, the potentialities, the emergence of certain things. Of course, they're not foolproof, that it's not an exact science. They're informed by the data that they use. But we live in a time where we have an abundance of data, and that's growing and developing and is interconnected. So it's a great opportunity to tap into such models, to use the wonderful equations that David uses and the data sets that we can deploy to try to really use these simulations and scenarios in a way that can serve, as I said, us here on Earth, as well as space communities later on.
I'd like to add to that, Steve, if I could. I'd like to just say why I got interested in modeling and the Club of Rome many, many years ago. I had a communications consulting firm. We built a model and we used very old, we didn't even have computers. It was called an advanced programmable calculator, but it worked. It worked. And we had a practical use for it, which was we were helping cities, towns, and states decide about the best way to franchise cable television systems. And there are two things I want to draw from that. One is, a model can surprise you. Uh, that's a good use of a model. So most people at that time felt like you just were never going to be able to wire poor communities. It just wasn't going to work, and it wouldn't be viable. But we started doing the models. It turned out cable television systems could be viable in low-income communities because of the density of the housing. So wealthy suburban communities, well, people had the money for it, but the houses were far apart. It was expensive. The lower income communities were close together. Maybe they didn't have as much money, but the cost wasn't that great. This was a revelation. It seems silly now to think it's so obvious, but it came out of building a model. And the other thing I would say is we were doing this in Newton, Massachusetts, and we kept hearing rumblings from MIT over in Cambridge. They were building a model of the whole world. And that's when we really got interested in the Club of Rome. And we were very interested in what might happen if you added another variable. We called it transformation. We didn't call it space migration, but we felt like it was limited. And I just want to strongly agree with everyone. This is a new way of looking at space migration and space exploration and space development. And instead of standing at opposite sides of the room and tossing disagreements at one another, like the classic, why are you spending so much money on space when you could spend it on Earth? Okay, instead of that, we also found back in the day, adversaries could come together to build the model, not to argue, but to see what is this thing going to produce. And I do think the whole idea that it might produce trade-offs and scenarios and options is really important to move that out of your mindset and forget the prediction side for the moment and look at the possibility that all the different players in the space field and environmentalists and other stakeholders, we would have something around which we could work together, which is building this simulation. And I think that's one of the great benefits of this way of thinking. And we have yet to see it for the most part in the space community and the environmental community and other stakeholders in this endeavor.
Frank, you just identified something that when I was first got involved with system dynamics and in general, that excited me most. And that's the point that you made where when folks come together that are, shall we say, at odds, it creates a discussion environment that is not something that is, I guess I say stimulates or catalyzes the disruptive and situation where people are fighting back and forth with each other. Rather, it takes them one step back and say, well, let's we've got this model. How would we develop this model? And so the people that are involved, even if they're on totally different sides, they're arguing more about, okay, how would that model be developed? And it takes them to the position, and Anahita, I think you probably could really understand this as well as anybody. It takes everybody in that discussion into a position where they're discussing the model, and they're not, fighting with each other. They're in a development discussion. And it is that system dynamic where people are working towards a common objective, which in this case would be to develop a model or a change or enhance a model, that in fact is the value of this system dynamic activity. So to me, it leads us to the question, of the fact that perhaps are you indicating that as part of the human space program activity, you're looking for folks to help you interact with you in the expansion of this particular model? Is that what I'm hearing?
Yeah, I mean, in general, we are, and we have been. I mean, at this point, I'm going to turn it to David to answer the question of having people help us. The goal certainly is to have many people help us put it together. Right now, we're looking to create what we call a minimum viable product, where it's pretty easy for people to interact with the model, and it's pretty easy for people to give input to the model. And definitely in the long term, we do want help, and we want it, as I said, eventually to be something the whole space community can use and policymakers can use. David, you might want to comment on where we are today and what we need other than money.
Well, and along that line, if I may also remind of the earlier question, you indicate you're working towards getting the model to a minimum viable product. Is it close to, or with some help, could it be brought to the point where we could start looking at the impacts, for example, of the proposed NASA budget reductions? David?
Well, right now we're barely out of the starting gate. So, and minimum viable product sort of sounds like a Silicon Valley appeal to venture capital or something like that. The idea is not to profit wildly from models of human space exploration or habitation, but the idea is to do a good job, and that takes money. So simply to buy the time of enough skilled people who are knowledgeable. So the challenge is pretty big, because you need to be able to anticipate things tens, hundreds of years in the future. So you can't make a model calibrated to today's data on today's large language models to get the effect of AI or something like that. Everything has to be parameterized from a perspective that you're comfortable saying, okay, this is how you can look at anything that might happen in the future. So, for example, there was a question in the chat of this meeting about how would you represent AI taking over in a model like this. And so the idea is not to get excited about the details of any particular technology, but just to try to parameterize at a broad level what the effects might be of some possible technology or some insult to the system or some thing like that. So the idea is in the original limits to growth model, we characterized human activity simply but with a stock of how much capital equipment there was on the planet, which is the sum of all the buildings and the factories and the support structure and the transportation. And then the question is, how do you parameterize that stuff? One question going forward, especially in the AI thing, is how many people are required to operate the capital? And that might dwindle towards zero in what's called the singularity. Another question is who owns the capital? In other words, what the positive prospect of the singularity is unlimited production of anything you want. And now the question is, are there side effects to that? And who has the money to buy all this stuff that's being produced? And so the idea is to parameterize things broadly in terms of what the consequences are of the hypothetical thing, not get into the details of exactly how it works and what its design should be. It's just, if you could have an AI that did the following, under what conditions does that create good outcomes for humanity as opposed to destructive or scary ones? So I'd say the prospect of where we want to go is pretty ambitious because we're looking so far ahead and we're looking at things that are poorly known right now of what resources are there off planet and how accessible are they. And so the idea is not to get trapped on exactly is Mars a good idea or is the moon better or is an O'Neill cylinder better, but just to, and this comes down to the controversies as well. The thing that Steve Hazer just mentioned about, and Frank, of resolving conflicts with system dynamics is you should and can embrace all the contrary attitudes in the same model. In other words, you make sure the model can express the mode that each party is saying, even though these modes are contradictory. And then the question comes down to a relatively more civilized discussion of what parametric assumptions have to be made to trigger one mode versus another. And we have, in my company, we've had a positive experience getting our quarreling factions together over a problem. And the problems range from California regulations on transportation vehicles. A recent one is chronic wasting disease. There's a disease that's sort of like mad cow disease in deer, and we have really quarrelsome groups coming together harmoniously around a model of how the disease is spread among deer, and in that single model you can see the activities and the interests of all the warring parties. So there are the game warden type people who are interested in the health of the deer. There are the hunting people who have different ideas. There are all kinds of the health people concerned this disease might jump to humans. And the idea is to make sure the model can express what each one of these people hopes and fears, and then get down to insights on what could be done that would minimize the conflict.
Well, I think that's a great explanation, but it leads us to the almost an insight perhaps that I'd like to press on a little bit more. The act of actively working to develop the model, as you indicated, David, can bring together disparate parties in a way that their position can be represented in that model. But more importantly, it gives the folks doing that development a forum where they can interact in a non-hostile way, because their views are being identified, recognized, and represented. Did I catch that right, Anahita, from a psychological point of view?
I think, again, David can answer that, but yes, I think he did. But as David alluded to, that these system dynamic models that he has designed, perhaps with him and his team, have real world application and are being used in the real world for multiple reasons. And again, My belief is that the World Bank and the UN and other organizations have also implemented these types of models for looking at energy and looking at water supply and looking at pandemics and so on and so forth. So these models do have real world application right here. For me, the important point here is not really just about recreating these scenarios for off-world habitation. It's about the benefits that they can provide for us here on Earth, for societies, for communities, for civilizations, and to learn more about sustainable living. And I think they may not show or reveal all of that, but they certainly will bring conversations and, as you said, bring people together who can have those types of discussions in a meaningful way. So I'll leave it there to see if Frank or David would want to add on to that.
Yeah, definitely, Frank. I'd like to hear your thoughts in this area too. As far as the human space program is concerned, it provides an organizational forum by which we and other individuals perhaps could get together. And you talked a little bit about task groups. Could you
Right.
elaborate a little bit more? Is that the mechanism that you're looking at for folks to come together to have these conversations, which can then be, if the situation is available and the funds are available, to enhance the existing model?
Yes, when we first conceived of how the human space program would work, as I said, we had three components: the task forces, the repository, and the simulation model. And the idea of the task forces, we had listed 16 specifically, and each one would tackle a major issue. I mentioned some of them. Also, we would, think about the economics and the question of military presence, everything we could think of that would be important to understand better before we really begin to establish off-world communities. And so over time, and we also had an idea of a repository of knowledge that the task forces would use. So for example, there's going to be an ethics task force. They might want to consider the ethics of terraforming Mars. Well, the repository could be helpful because we could have every article about terraforming Mars in there. And also the model could be helpful in looking at what that might look like. But, the three components have become increasingly more integrated, I would say, in that I think the simulation model has become more and more important to the three components. And it certainly has drawn the greatest interest because when I first started talking about the blueprint, at one meeting, someone said, well, what's the point? How many studies have there been? They're being doorstops and they're sitting on, they're sitting around in somebody's office. The great thing about if we can produce this model and sustain it financially is there'll never be an end to it. It will always be growing and evolving. And so I think that the three components are now increasingly more part of a whole system. And again, if we come out with a blueprint and we do say this is the plan that we currently think will work best, if people object and don't like elements of it, we can go back to the simulation. One other aspect that we haven't talked about, and we haven't spent a lot of time on this, but there are other ways to do simulations, and there are some members of our team that are very interested in that, which is what is often called a tabletop simulation or effort, where you assign people different roles in a future situation, and then you have them act out how they would respond to that situation. And what we're building with the computer model could actually create scenarios for people to work with in a more direct way. And I think that's a tremendous opportunity, again, for people to come together and work together on a common project with a common point of view.
I think just to add a little bit to what Frank was saying, the other day in regards to tasks and roles and how people perform in these communities and how they interact with one another, and that being a very important aspect of this exercise as well. And the other day I was walking with my daughter and we walked past an ant colony, and it had made these stacks of underground caves and lava tubes like spaces for itself, and left mounds of bits of dust outside, and you could clearly see that there were different roles and tasks for each ant, and it made me think about our endeavor in terms of going off world and trying to actually think about who's going, what are the roles that we're going to define this community, what are the essential roles for this community, how they're going to interact with one another, what are the power dynamics, what are the authority structures of this community, what are the economic systems of this community, and these are questions that many people are trying to have. But this, I think, as Frank said, we might not be able to provide answers for everything, but what we can do is simulate scenarios that can give us different outcomes, potential outcomes, emergence of different outcomes, that we can then review and discuss as teams and collaborate together to then think about that most attractive version for all of us, for all of humankind.
So do we end up with a Star Trek future, an Expanse future, or what kind of thing? Yeah, I hear you.
I suppose we can look that far ahead, but also we have, civilizations have collapsed before, right? It's not foolproof that because we're advanced that we are. So I'm talking a bit more about the why of we might be doing this. It's about pulling teams together, bringing people together. It's about coming up with ideas, thinking about the most attractive ideas, what works, what doesn't. But also it's civil, the other why is that we are not a foolproof civilization, that there is a risk that we can collapse or our civilization can decline. And so we have to always be thinking about not only how we preserve nature and Earth, but also, Earth is quite robust, but nature and us and life as we know it, but our civilization. And I think that gets sometimes disputed, but I think actually that is a reality. We have cities in Jakarta that are sinking. We have volcanoes in Italy that are almost erupting, and slums in Mumbai that need addressing, mega cities that are growing out of control, and so we really need to come up with real solutions. And this could be a plausible solution if we get enough stakeholders to the table to have these discussions.
Well, it certainly will. These kinds of discussions, I think, are gonna provide everyone with a real good forum for getting some perspective on where do we go, when do we go, that sort of thing. And as Frank indicated, that the data repository for his task force groups, Beyond Earth is already, as to let the audience know, Beyond Earth has already started to work with Frank and in providing, for example, the various working group reports on many of the subjects that have been discussed here today, and as well as a number of our journal indications. So that those things are going to be linked into this data repository for these task forces to work with. Let me ask this question. Has there been consideration about the use of the task forces to help ID and recommend those areas to begin to actively implement within the model that you guys are developing?
Well, yes. I mean, I think that first of all, there's a dual use here. One is a task force can behave like the old-fashioned task forces that meet in a hotel room in a pleasant city like Paris and spend a couple of days thinking big thoughts and then issuing a report. That's one that's one way in which it can happen, and that's fair enough because it can be useful. Again, the ethics of space exploration are a big topic right now, and I think that could be something we could contribute to. But then the outcome of what the task forces produce could also be integrated into the model and could become part of a consideration of the model. One thing I would mention is we did a little test a couple of years ago where we had some proto task forces, and we didn't have a model for them, and we really didn't have the repository, but we created, I think, 5 or 6 proto task forces, and it was an interesting experiment to see how they developed, and it was instructive for our future because honestly, some of the task forces had a lot of difficulty getting a consensus and getting the work done. And other task forces, like the one that Anahita chaired, did a terrific job. And Anahita, what was it like doing a proto task force? It might be helpful to people to know what that experience was like.
Well, it was a fantastic experience. I'm always eternally grateful for the opportunity, Frank, and the Human Space Program. It really was a test bed for how teams come together, work together, formulating leadership styles, and thinking about what types of leadership works with different people in, different groups, and how to get the best out of people, and how to sometimes reduce your ego when you're in a leadership role. This is a much smaller leadership role. There was 9 people on my task force. But I think as a team, you come together when you really pull from the strengths and abilities of the team, and that was, something that I learned through the experience. But also, what we learned as a team, I think, was that the task force needs to be extended out, despite some of the benefits and challenges of working in a team. That we would benefit from having a much more specialized task force, but also a larger task force. And again, having that data bank in order to keep accumulating and adding to the whether it's research or knowledge base or the discussions. And now we've got AI discussions happening as well, so we can pull AI into that as well, and really to develop that into a cohesive system. So it's a fantastic opportunity, really, to bring, I think, not just great minds like experts, but other great minds within the community, the citizens, people, and try to really incorporate them. So I hope that's answered your question a little bit, Frank.
Yeah, perfect. And again, we've talked a lot about the model today. I do think that, however, I do think the task forces are going to be a dynamic part of the whole modeling exercise. And again, the task forces could be comprised of people who don't necessarily agree all the time. And that might be a good,
Good
you
thing.
know, testing ground for can the model really manage opposing points of view or what appear to be opposing points of view.
Yeah, do the other thing that I thought was great to observe in the task force, and I'm sure I contributed to this equally amongst my team members, was the emergence of, I'll call them fractals of chaos beginning to emerge at certain points. Now, that could be due to poor leadership or aspects of, there were several leaders on the team. But what that indicates to is how easily humans can be pulled into in and out group dynamics, and how that can reflect in terms of how we cooperate and how we, perhaps, as you said, where conflict can arise. But disagreement doesn't always have to be a bad thing. In fact, if we can create the space for disagreement, we'll learn a lot more. But equally, those types of micro tests are a great example of some of the challenges we may well face in a much more exaggerated way off world. And again, that social psychology side of it will be an important element. And again, David may speak to this a bit more, and Frank, you may, but thinking about how we can incorporate, once we have grown or developed this program to where it needs to be, thinking about how we can integrate other technologies and systems in order to provide different angles, the macro angle and the micro angle, and how we can incorporate that into the system. And I will stop there and hand over to David.
Well, synergistic with Anahita's comment, I noticed in the discussion or the chat, someone named Phil said, solving all the world's problems is great, but do we have a specific goal that might galvanize short-term interest? And he suggested, for example, what would it take to get a permanently crewed base on Mars? Obviously, when you're dealing with projections of things that might happen in the future, there are going to be immediate pressures and temptations to go micro, as Anahita just mentioned. But there's already a lot of work at the micro level. And the question is, how do you, as Anahita suggested, incorporate that and take advantage of it? So a lot of people have already worried about bases on Mars at a level of detail that we won't even try to address. But one thing we want to be aware of in moving forward on this sort of big perspective model is to take advantage of any results from other models or from data collection or from engineering designs to get realistic ranges of parameters at the more macro level. So I think we don't have ambitions to start competing with all the aerospace and academic models of the details of how do you run an O'Neill cylinder and how would it be constructed and where would you get the resources and exactly how would you do that. The idea is just to parameterize these things according to what does it cost in the way of energy, money, or whatever to do these various things, and look at scenarios of under what conditions does the enterprise prosper, under what conditions is it vulnerable. One thing I remember about reading the histories of early computer development is anytime you get, in those days there was a thing called a vacuum tube, and anytime you get suddenly, vacuum tubes were designed for radios and such where you'd have a handful of them. And now we're talking about filling a room with tens of thousands of these things in order to perform calculations. And the question is, if you have a room full of thousands of things, each one of which has a finite life, and it becomes almost guaranteed that at least a few of them will be burning out every second, what do you do about that? And this image has returned to haunt my thoughts about space communities, because one thing that we see with the fledgling space communities we have now is they're extraordinarily fragile. They're built with extreme limits on weight and energy consumption, and therefore it would be very, very easy for one human to bring down the entire environment of, say, the International the space station, or the Apollo extremely thin-skinned landing craft, where one accident by one astronaut could fry the entire operation by punching a hole in the wall. So if you imagine an O'Neill cylinder with 10,000 people in it, what level of screening do you need to try to prevent someone suffering from a psychosis of some kind or religious conviction or something that causes them to want to sabotage the enterprise, or just to inadvertently do something that they don't know that would sabotage the operation? So there are all these issues of, as Anahita said, how do you get any civilized organization to keep going? That's a serious question, and I think I've gone off track here. But the idea is to, in the same way that we hope to integrate competing opinions about things, we'd also like to take advantage of adjacent studies at different levels of detail that could provide facts and constraints and parameters.
Hey, Steve, this is Steve Wolf here, just jumping in. I want to make sure there's a whole bunch of really good questions from the audience. I know we're not going to get to all of them, but I know, Steve, you're going to look to pull some of those questions in. Really great talk so far.
Yeah, I think that the panel has actually been doing a pretty good job of looking at and keeping an eye on these some of these questions here. In the overall context of what we were just talking about, however, are you the question? Because I've been involved in some of these groups, task forces as well, and normally what happens is they pick an area, a broad area. In the case of the this particular program, you folks are looking at, basically what does it take if you were going to expand, human civilization and migrate human civilization into space? What might that look like? And as you were talking about, David, are we talking, individual colonies? And if you're going to build those colonies, what are all the problems that might be involved? You were talking about, sabotage, terrorist attack, pirates, whatever you want to call them, for example. Just how how robust are those? Or maybe the question then becomes of this group, what do we have to do to prevent those kinds of things? For example, let's talk just about moving goods logistically back and forth, like we do here on Earth. We've got a container of things. How are you going to monitor that container and things like that? So, are we talking here about discussions and groups in that context, or what is the context of the overall focus of these task groups?
One thing I'd like to say, and you said it, but I want to build on it. We are not actually talking about leaving Earth. We are talking about advancing human civilization into a larger ecosystem. That's the solar system, and Earth is part of that. So as we look at all these different scenarios, and we start to imagine human communities in very large numbers off of the Earth, what we really want to do is develop an overall plan that would, again, at the macro scale, be kind of like what you do when you do city planning or regional planning, where you ask yourself, what's the greatest good for the greatest number? What's the best way to do this for the environment, etc. So we will probably have an overview of what these communities look like. And as David said, when we look at the individual communities, we will ask ourselves broad questions about them. And, we'll want to know how are they going to function most effectively. But, I'm an O'Neillian. A lot of us are O'Neillians. Jerry O'Neill had an ability to think about what a space community would look like. And of course, I always say, since we are in space, we're in a space community. The Earth is a space community. We're talking about building more of them. But again, I talked before about surprises. O'Neill and his group, and they didn't have a task force, but they were in a classroom. They realized that building on a planetary surface might not be the best way for a highly technological civilization to advance into the solar system. That's when they came up with the O'Neill approach, the O'Neill cylinders and so on. So the other thing I would say, as we do this, we need to be prepared for surprises. We didn't know when we did the proto task forces how that would turn out. We found out. When we started working on the model, we didn't know exactly where that would go, and we're finding out. So in a way, we are explorers, and we are going to be exploring the solar system conceptually and sort of looking ahead to what it might look like. And I think we need to be prepared for serendipity and unexpected outcomes. I think somebody in the chat said we hadn't answered their question yet. Phil, what?
Yeah, Phil is questioning about more, how do you use models, and maybe I can inject something here. I was involved in a group of politicians, engineers, scientists, business people, et cetera. A whole cross section, as Ananita had indicated, that of different people from different perspectives, but they came together to ask and discuss a question way back when in the 80s, and that was, what would be the effect of having a fully reusable, safe, reliable, and low cost, space transportation? What would that have? What effect would that have on the overall prospects of, people moving to space, on defense, on all sorts of things? And so, that was the discussion. From that, I actually developed a model that tried to develop at least a causal loop portion of a system dynamic model on what that might look like. And this was in the early 2000s. But more importantly, out of that group, through that interaction of disparate perspectives, a lot of insight came into play that played very heavily on the development of strategies, potential policy campaigns, implications, and things like that. And we're starting to see, and implementing them over the years, including things like creating prizes like the X Prize and things like that were discussed. And we're seeing now, beginning to see the impact of this reusable rockets is starting to change the way people look at things. And those factors wouldn't have come out unless you had that kind of dynamic environment, task force environment, and the ability to begin to look at it in a structured fashion. But as we've indicated, accept everybody's perspective, good and bad, and that. And we had some interesting bad what's going to happen if the Russians do bad things, or if the Chinese do bad things, and how are you going to protect against them? All sorts of things like that. But it got people thinking in different ways and seeing things from a different perspective that they hadn't thought about before. That was very powerful. I mean, it took 40 plus years, but at least it's got us going in the right direction. So I offer that up as an example of one perspective on how this overall process that you're presenting and the ability to begin to model those things can have some beneficial long-term effects.
Mm-hmm.
If I can just quickly interject to sort of respond to what you've said and perhaps partially answer some of Phil's questions as well as other people's. I think so. Phil is saying, can you not look at the smaller scale? And I think David and Frank both sort of tried to answer that question in terms of what we're doing it and why we're doing it and why we're doing it on a larger scale. But from my perspective, this type of macro perspective can really help us look at a system overview of the system and really, in a sense, not exactly, but reverse engineer then to look at the smaller aspects of that system. So I think it's actually really useful to have these different scenarios where you have this sort of overview, larger scale look at variations of the system and how things can play out. And then from that space, then you can look at, as you said, how you can bring teams together, whose work can complement one another's work, and perhaps how you can create smaller structures that aren't just standalone modular structures, but actually structures that can complement a whole ecosystem out there in the space environment, right? How the galactic superhighway idea in terms of trying to think, how do all of these systems complement one another, work with one another? And so starting from that end, I think could add a lot of value.
That's great. Say, Frank, the question, has come up also. I think that begs a bigger question from Daniel. The question is, what are the current task, groups, and how open are you to discuss possibly creating other task groups?
Okay, good question. So as I mentioned before, there are 16, and I think I've mentioned a few of the specifics. If anybody is really interested in a list, we'd be happy to share that, but let me just think out loud for a minute. There's a group on religion. Incidentally, the proto task force in our exercise kind of turned into an anti-religion task force. They basically got into how terrible religion is. So there is a religion task force, ethics, economics, environment, military, and hard science. Also, I think I mentioned ethics because that's the one that kind of interests me the most. Um, so it's that kind of thing. They're not complicated. Culture and arts would be another one. They're pretty straightforward aspects of human existence. And we'd be open to adding task forces because right now, other than our proto task force exercise, we have not focused a huge amount of attention on the task forces. I would say one of the issues we're looking at, and we'd love to hear people's thoughts. We'd like to break away from the idea of experts sitting in a room and talking, or experts on Zoom talking. We'd like to get much larger participation in the task force process. And that might be something we could do using blockchain and other new technologies. So we're open to how we're going to do the task forces, and we're also open to other specific task force titles.
Great. Well, we've got about 4 or 5 or 6 minutes left. I'd like to give each of you the opportunity for any final comments, and then I want to pose one very key, I think, final question to the overall members here of the panel. So, Frank, did you have any final thoughts you'd like to share?
Yeah, a couple of final thoughts. We've spent quite a bit of time developing the model and developing it conceptually and beginning to do some programming for it. The one thing I do want to emphasize, and I'm sure it's obvious because for any space enterprise, it is something that you have to consider, and that's funding. So if anybody has heard this webinar today and thinks this is a great idea, if you have any idea of a foundation or an individual or a corporation that would be interested in supporting this, that would be terrific because we can only go so far on volunteer help.
Okay, David?
Yeah, I'm intrigued by Phil's last missive in the chat thing. He asked 3 quick questions at the end, but I think it runs right to the point of summarizing what we've been talking about. So Phil said, how is it that combining things into an overview is better than the sum of the parts, and who would use it? I think the idea is the reason it's better than some of the parts is that it can embrace quarreling parts. And in terms of who would use it, the perspective is one of humanity. So Phil mentioned, suppose you have a detailed model of logistics chain to Mars. The idea is you can use the integrated model to decide how important it would be to build that particular thing at its cost, or how urgent it would be to double its efficiency to make it balance with everything else. So the idea is you can use it to test feasibility, to look, as Anahita was saying, look for things that you've forgotten about that might get in the way, and also to balance, to set goals of what do we need to do in order to achieve this greater good.
All right. Anahita, do you have any final comments, please?
Just to say thank you for the wonderful opportunity. It's been great having this discussion. Hopefully we can extend these discussions out even wider. I know Frank and David have been doing various webinars, and so you can catch their work on the World Wide Web. So I just want to say that, as I've sort of been saying all along, really, that these types of models have benefits here on Earth for us, as well as helping us conceptualize and perhaps plan for future off-world communities in space.
Excellent, excellent thoughts. I couldn't agree more. So here's the big final question. How might the folks that are watching, or others, connect with the human space program to get more information, or potentially support and or assist in enhancing the current model to possibly answer their specific policy or company concerns?
Well, I'm going to go ahead and put my email address in the chat. And if anybody else on our team would like to do the same, I think the best thing to do is get in touch with us, or get in touch with Steve and Steve at Beyond Earth. But here's my email address, and I'd love to hear from anybody.
Do you folks have a website?
Yes, we do.
Okay, that might be of help too.
Yeah, let me get this in. And yeah, it's just humanspaceprogram.org.
Very good.
It's going through a reconstruction, but it's there.
Excellent. Well, I'd like to thank everybody while you're doing that for all our panel members here. This is very interesting, and having participated in groups that have task force type groups in my past, and working to develop these kinds of models, I can't say enough about not just the models themselves, but the process of developing those models and the insights that can be gained through that process. So with that, I want to switch it back over to Steve Wolf for any final discussions or comments he might have.
Thank you, Steve, and thank you so much to Frank and Anahita and David. Really a great discussion. If I can, I just have, well, my observation. I've been at this for as long as Frank has. Maybe, well, and David, we're all of a certain age, I suppose. And the challenge when you're talking about human expansion into space, human settlement, has always been, how do we get there from where we are right now, right? So, and that's always hard, because when you look at an O'Neill colony of 10,000 people orbiting the Earth, and you compare that to, 10 or 12 people in the International Space Station, which is, by comparison, extremely modest. How do you bridge that technological gap? And I think this model can go a long way to help people understand the the pathway, right, from where we are today to getting to that future. Yeah, I am reminded of one of my favorite book trilogies, the Foundation trilogy, where we're in the where as Isaac Asimov was in the business of looking, of predicting the future history of the world. And you guys are a little bit in that domain, which is kind of exciting too. But I think you're developing quite a tool. I wanted the question I had though was you talked earlier about the minimum viable functioning platform or model so that everyone can kind of get in there in a sandbox, I suppose, type of environment and kick and play around with it. Are you is that something you're going to be able to do without funding, or is that something you just can't get there unless you get some shekels in and do that? So I'm just curious because it'd be great if we could get something like that to look at and play with in the near term.
I'd like to have David in particular, who's our modeling leader, comment.
Mhm.
Uh, we could make a we will make a good start toward the minimal viable product, but I think we will need funding to get to where we want to go.
Okay.
David, thought?
Well, it has to do not only with feasibility, but with timing. So with minimal or zero funding, things just take forever because they're, volunteer time in the cracks. What's needed to make this good is there's a big community already of people who have specific models of tangible things and knowledge of some of the parameters that we need. So it'd be silly to just stay isolated and work on this piecemeal. And so part of the need for money is to embrace and engage all the necessary background research and other groups to do this properly and efficiently. So until then, it's going to be proof of concept kind of stuff as opposed to anything that's worth standing behind.
Well, again, we want to be as supportive as we can, as Beyond Earth Institute can. So, really, congratulations on what you've done so far. So, look forward to more developments in the near term, Frank, David, and Anahita. I want to I want to thank everyone for coming. We appreciate everyone who made comments or asked questions we weren't able to get to. And the Beyond Earth Institute shortly will be announcing information, details about our upcoming or our next Beyond Earth Symposium. Just a hint, we are moving from a fall date for our sessions. We typically have been in November. We will now be, we're looking at early dates or I should say dates in 2026. So we'll be having our event in the first half of the year. We'll be putting out a save the date on that shortly. So we look forward to that. And thank you all. We have a couple of great webinars that were scheduled. You'll be getting information about those. So with that, I want to thank you. Thanks again to our panel. Thank you, Steve Hazer, for great moderation. And with that, thank you all, and have a great day. We'll see you next time.
Thank you.
Thank you,
Thank you.
everyone.